our job in this problem is to actually derive the formula for a circle, so whose center is at hk. Okay, this is typically done in an algebra class or a pre-calculus class. Usually the instructor demonstrates how to do this, and most students really don't understand what's going on. They just try to follow along, and they usually copy it down in their book, but they never really go back to it because it's never asked of them. So here's how the problem goes. We're just going to graph out an arbitrary circle. I actually want to draw it a little bit bigger. So, okay, there's our circle. It's not great, but it'll get done. Now it doesn't matter what quadrant it's in. I'm just going to put it in quadrant 1. Again, this is arbitrary. The only thing that we are given is that its center is at hk, and it has a radius value of r. So what we're going to do is we're going to pick an arbitrary point, and we're going to call it xy. We know that the length out to that arbitrary point, this length right here, is r, the radius. Now, what we need to do is come up with an equation involving x and y and r. Okay, and we want to show that x minus h squared plus y minus k squared is equal to r squared. We want to show that this guy holds. Okay, so here's how we're going to do it. First, I'm going to take, actually I don't even need to do that. I'm going to take a look at this guy down here, this length. Okay, so I want this length, this red line. Well, we know that this guy right here, this point, its ordered pair, it has a height value of k, right? Because if I go back over this way, it has a height value of k, but its x value is really just x, because it's whatever x this is, this guy's got the same value. So this is x comma k. So the length of the red line is the difference between the x values. So the length is x minus h. Okay. Now, if you're really concerned about that and you want to make sure, well, what if x is not more than h? We could put absolute values around it. It's not going to matter because in a minute we're going to be squaring that guy. Okay, so we've got x minus h. So that's this distance right here. That's what we call our delta x. Now let's go ahead and grab this guy here. The same story applies. This guy up here, okay, between these two, is up at a height of y. Come back to the axis here. It's up at a height of y because of this, and this guy down here was at a height of k. So this length right here is the difference in the y values, the change in the y values, which is y minus k. And so, if you take the red line, which is x minus h, and you square it, because this is a right angle, think about why that is, and then you add that to the yellow line, length squared, you're going to get the hypotenuse squared. And that's it. That's all there is to prove it.